Innovation and Design Thinking. IDT. VTU. Module 3. Design Thinking in IT. Case Study. Agile Software Development in Virtual Collaboration Environments. By J. Babu. Agile Software Development in Virtual Collaboration Environments. This is a research work carried out by Robert Hirschfeld, Bastian Steinert, and Jens Link, Software Architecture Group, Hasso-Plattner Institute, University of Potsdam, Germany. Agile processes are gaining popularity in the software engineering community. Authors investigated how selected design practices and the mindset they are based on can be integrated into agile software development processes to make them even stronger. In a first step, authors compared agile methodologies with interaction and product design methodologies and discovered that both fields have much in common with respect to their underlying principles and values. Based on their findings and by applying both methodologies, they improved collaboration support for geographically dispersed software development teams. Authors designed and implemented Project Talk and Code Talk as part of their XP Forums platform. Independently of their geographical location, team members can create and maintain user stories with Project Talk. Code Talk enables team members to efficiently communicate their concerns regarding development artifacts in an informal manner. Agile software development processes are increasingly followed in software development projects that deal with complex domains and require continuous interaction among developers and with customers and prospective users. Agile approaches such as extreme programming or Scrum are people and code-centric. Based on a high-quality code base throughout the entire project, developers can respond almost instantly to customer needs and requests. Teams can quickly make progress in providing the desired technical solution due to short development cycles and incremental explorations. Design thinking as a process has interesting aspects to offer, not only to designers, but also to software engineers. In this study, authors extended agile development processes with elements from the design thinking approach to make them even stronger. Authors' enhancements will explicitly support both developers and customers to explore divergent alternatives and to converge on a decision or solution whenever necessary and possible. There is also the trend that project teams tend to disperse around the world. Distributed development is getting more common, requiring team members to resort to means other than face-to-face communication to organize themselves, to collaborate, and to keep in touch regardless of geographical location. See the figure. Figure shows the conceptual project of integrating design thinking in agile software development in virtual collaboration environment. Author's approach is twofold as shown in Fig. First, to extend state-of-the-art agile development processes with elements of design thinking to allow software developers to benefit from the mindset of design. Second, to employ our extended software development process to design and implement tools supporting this process, keeping everyone collaboratively involved. Authors extend agile development processes and to provide appropriate tool support within a virtual collaboration environment. Their work involved three important aspects: agile development process, design thinking, and virtual collaboration. Design thinking for agile software development. Most agile software development processes are people and code-centric in that they foster interaction between project participants, grounded on short and many iterations, each of which resembling a full development cycle including planning, analyzing and prioritizing requirements, designing, and testing. Risk is minimized by producing a running system in every such iteration in a short period of time. The most popular representatives of such processes are Scrum and Extreme Programming (XP). Scrum is a high-level process framework that defines roles and practices. See the Figure 2am. Figure 2am shows the Scrum process skeleton that has two main cycles. The launch cycle, 30 days, represents a development activity that leads to an increment of the product to be built based on the requirements and the budget allocated for their implementation. It groups several short cycles, 24h each, that cluster daily activities of the team members inspecting each other's activities, proposing next steps, and suggesting corrective actions if necessary. Compared to Scrum, XP is a more disciplined method. It focuses on the strict application of programming techniques representing best practices, on clear communication, and on teamwork. XP assumes short development cycles that allow for early feedback based on actual code. In this study, authors investigated how elements from design thinking such as divergent and convergent thinking as shown in Figure to be need finding, brainstorming and sketching, and the preservation of ambiguity can be integrated into agile processes like Scrum and XP. Collaboration support for distributed development teams. Both design thinking and agile software development projects rely on small teams working closely together. Informal direct communication and physical tools and artifacts such as whiteboards, sticky notes, and story cards are preferred means of expression and interaction. For that to work, team members need to be co-located to take full advantage of the benefits offered by these tools and artifacts. Due to organizational structures and economical concerns of modern organizations, distributed development is getting more popular, requiring geographically dispersed project teams to collaborate across space and time. Authors argue that there is a need for virtual collaboration environments as a shared place for project participants to meet, to work, and to collaborate as informal as they are used to. One key challenge addressed in this study is the computerization of these informal but important tools and artifacts without either losing their advantageous properties or by compensation for their potential loss. Authors compensated for such losses with advantages, offering the new media of virtual environments, using their power and nearly unlimited space to go beyond the possibilities and constraints of the physical world. Examples of tool support to be provided by virtual collaboration environment include whiteboards that are unbound in screen a state, persistent, and searchable even after some of the design phases are finished. This way, early design decisions are available to the program maintainers when needed. Furthermore, authors want important relationships between design and development artifacts to be made explicit and preserved for continuing efforts and future reference. Code editors, for example, can be annotated with the alternatives considered in previous convergent-divergent design phases. Design thinking for agile software development. Relying on a natural approach to learning, that is comparing the new with facts and knowledge already understood and internalized. Authors examined design-related topics on innovation, need finding, interaction design, and creativity techniques from a software engineering perspective, allowing them to better understand and integrate new interesting elements into agile development processes. First results of this comparison between design methodologies and agile software engineering topics reveal many commonalities. Common values. Recognizing similarities between agile and design methodologies has been authors' motivation for investigating the combination of XP and elements from design thinking. Authors studied literature on design thinking and interaction design from a software engineering perspective, and identified many commonalities with respect to the values of respective methodologies, values referring to underlying principles of the methodologies, the principles upon which concrete techniques are based. The commonalities are 1. Wicked problems. 2. Close interaction. 3. Go for feedback. Wicked problems. Software development projects are confronted with wicked problems. The term wicked problems refers to problems that are not well understood and thus difficult to describe. The problem becomes, however, clearer as one moves ahead to the solution of the problem. The closer one gets to the solution, the more one can understand and describe what the actual problem is. In the field of design, it is reported that design teams usually face this kind of problem. Moreover, solving a problem that is understood well may not be referred to as a design activity. Close interaction. People interacting closely with each other exchange a lot of knowledge and opinions, which in turn supports making progress. For this particular and other reasons, agile processes such as XP strongly suggests a close interaction amongst all team members as well as with the customer. The value of close interaction results in recommendations of concrete practices such as on-site boards, pair programming, collective planning sessions, collective code ownership, or small but regular releases. Close interaction is also a key aspect of design activities. Many designers work with their customers using different methods to elaborate their understanding of the domain from multiple perspectives. As an example, the collaboration of team members having different areas of expertise and experience further supports the exploration of the problem and solution space. It eases the creation of a multitude of divergent ideas and supports their connection and composition. Go for feedback. Iterative and incremental development is the foundation of all agile methodologies. In each iteration, a next running version of the system is created and delivered, bringing value to the customer and allowing for feedback on this running, executable prototype that is used in real work settings. Being close to design processes in this respect, XP recommends to have actual users on site. This enables early and direct feedback during the workout and implementation of all details of the higher-level concepts and ideas. Programming is also an activity resulting in feedback. Developers get feedback on their understanding of the program domain and about the quality of their implementation. For similar reasons, designers are encouraged to create many prototypes and to work with them, getting feedback on the forms and materials. Approaches to combine design and development activities. Basically, there are two different approaches to combining the work of interaction designers with the work of software engineers. 1. A waterfall-like approach, left side. 2. An iterative and incremental approach, right side. See the figure. The left side of figure shows a waterfall-like approach, conducting design activities first and handing over the resulting concept to a development phase. It is the task of the designers to understand the problem domain of the users. Based on that, they develop several concepts addressing the user's needs, work the concepts out, and align them to each other. The overall and finalized design represents the requirements on the system that is to be realized by the software developers in a subsequent stage. The right side of figure depicts an alternative approach that is based on the notion of iterative and incremental development. Over multiple iterations, designers and software developers simultaneously work on the design concepts and the code base respectively. This approach is built on the observations that getting all requirements right first is rarely possible, that requirements can and will change during the project lifecycle, and that the understanding of the problems evolves as we get closer to their solution. The iterative and incremental approach implicates that the overall design is neither final nor complete until the end of the project and can be changed at any time during the course of the project. The problem domain and the corresponding set of requirements has to be separated early in the project so that designers and developers can work on a prioritized subset of requirements and problems in each iteration. On the one hand, changes to the design result in additional development effort. On the other hand, the iterative approach allows for taking advantage of new insights gained during the ongoing project development. With that, this approach allows both designers and developers to embrace change in most if not all different aspects relevant to the project. Design thinking and agile development methodologies and prototyping techniques such as sketching and paper prototyping support the exploration of alternatives and eases getting insights and making progress. The main goal of a prototype is to reveal misconceptions and to improve the understanding of the problem domain. In this sense, each version of the software system delivered after an iteration can be considered as another kind of prototype. In contrast to a sketch, for example, it has a higher resolution, but it allows for getting different aspects of feedback, in particular the adequateness of the current solution in the target settings, when real users work with the application in real work situations. Virtual collaboration. Close collaboration and communication is vital in XP projects amongst team members and also with customers. Development teams tend, however, to disperse around the globe and thus have to resist to means other than face-to-face communication. In this study, authors integrated and developed tool support for distributed development teams to allow for informal communication and efficient collaboration despite geographical dispersion. Amongst others, authors have developed Project Talk, an application that supports collaborative planning activities in distributed teams. Project Talk's design allows for working with story cards in a similar way as it is possible with physical artifacts, by still providing the advantages of a digital solution. Authors also have developed Code Talk, an extension to an development environment that enables distributed developers to have conversations about source in an informal and efficient manner. Along with other tools, such as Project Talk, Code Talk was used in several development projects and showed its usefulness. Bringing physical artifacts to digital environments. XP, similar to design processes, heavily relies on collocation of all teams members and on physical tools for communication and organization such as index cards and whiteboards. User stories are the central artifacts in XP teams. They form a concise description of the customer's requirements written in everyday language. User stories are elaborated in concerted planning sessions with the customer and persisted on index cards. These cards are usually managed by pinning and moving them on a whiteboard, being visible for the team and indicating progress of the project. Bringing all these information from the physical whiteboard into the digital world promises a multitude of new possibilities, such as having unbounded space or support for full-text search. In addition, having these artifacts digitalized provides a good basis for supporting and encouraging close collaboration in teams working geographically dispersed. Prospective collaboration software should thereby incorporate as many strengths of physical setups as possible. Learning from others about the flaws and strengths in this and other respects, authors extensively benchmarked existing software solutions supporting agile processes. As one important result, it turns out that a main challenge is the design for interaction with huge amounts of information within limited dimensions of a computer screen. Many solutions have decided for tabular representation of user stories, actually causing a feeling of information overload. All solutions distinguish between viewing and editing information and usually offer a number of forms to alter contents of user stories. This design does not harmonize well with the card metaphor and requires a decent number of clicks for simple usage scenario. By trying out available solutions and actively working with them, authors became aware of that the design of the tools influenced the project team in working with user stories. Depending on available space, team members cut descriptions down to single bullet points or fill out many different fields of the forms, making stories too formal and complex. Getting closer to a solution candidate meeting the needs, authors continuously designed user interface concepts, created various prototypes, implemented the prototype concepts, and used the implemented version during the daily work. See the figure. The left column of figure shows prototypes of different concepts developed in the course of the project. The right column shows corresponding versions of implementation called Project Talk. The last picture at the bottom left shows a new prototype for Project Talk that is currently implemented. This current version includes some innovative user interface concepts for easily browsing large amount of project artifacts. Multi-user, multi-account, single-screen interaction. Integrating single display groupware (SDG) concepts with more traditional groupware, such as wikis or project management software, requires reconsidering the way of interacting with and designing for users. Project Talk integrates SDG concepts, enabling co-present team members to collaborate using the same application instance. Users are provided with separate input channels, allowing them to contribute with the need to synchronize. While users often have an account and interact with the application in a way specific to their account, traditional SDG concepts do not allow users to act on their own behalf. Merging characteristics of asynchronous groupware and single display groupware. By employing SDG concepts, authors provide XP teams with interaction characteristics similar to working with physical tools. XP teams traditionally rely on these physical tools, such as index cards and whiteboards, for communication and organization purposes. Bringing all these information from the physical whiteboard into the digital world would enable a multitude of new possibilities, such as having unbounded space or support for full text search. Additionally, it enables remote collaboration, because virtual whiteboards, unlike physical ones, can be shared over computer networks. See the figure. Figure shows a screenshot of the application developed by the authors. Multiple users, represented on the screen by colored mouse cursors, interact with a virtual whiteboard. Every user may open their own context menu. Using physical tools such as whiteboards and index cards, team members are able to act independently of one another without the need to synchronize on pens. Traditional applications, however, only support interaction with one user at a time. The need to synchronize on application control impedes spontaneous interaction and reduces social dynamic in comparison to a physical whiteboard. Therefore, authors enable multiple users to interact with the application independently. To further increase the dynamic of a session, users are able to join or leave a session at any time. Authors also incorporated screen sharing technology to support distributed XP teams. Remote team members can share planning sessions and interact with the same shared screen. When multiple users interact with a single screen, traditional applications are unable to distinguish acting users. These restrictions of current concepts lead to issues concerning authorization and traceability. See the figure. Figure shows a typical multi-user single-screen scenario. Figure shows two users collaborate on a shared screen, each user having its own cursor. Figure A shows one user moves a user story from one iteration to another. Figure B shows this user action leads to a change in underlying object structures. Figure C shows if the application is not provided with sufficient context information about the currently acting user, it is unable to validate privileges correspondingly. The inability to distinguish multiple acting users does not only lead to undesired modifications, but also to unintended restrictions of users. The following questions come up now to be answered. How might an application be designed to allow multiple interacting users logging in and logging out? How should the user credentials be managed? How might UI events be distinguished by acting users? How might the application make use of this distinction and link application actions to users? How should applications be designed to deal with multiple interacting users having different privileges? Answers to the above questions leads to the development of a platform support for multi-user multi-account interaction. Platform support for multi-user multi-account interaction. An application featuring multi-user single-screen interaction requires special support in the application's platform, such as handling the events from multiple, similar input devices independently from each other. In addition, if multiple remote users should be able to work in same way as local users, and if UI actions should be linked to the users, an adequate concept representing the users and their actions is needed. The concept of hands has shown as a meaningful approach to represent and manage user interactions. Hand objects obtain their event data from the corresponding input stream autonomously. By using this concept, additional input streams can be integrated. Multiple hands, that is, mouse pointers and cursors, can be controlled by different input sources. Current operating systems, however, support only one system cursor, and input events from different devices are merged into one input event stream. To bypass the operation system's behavior, authors developed special support for Squeak's virtual machine VM. The design of our VM extensions allows attaching and detaching input devices during the application's runtime. Hand objects further abstract from concrete input sources and provide a defined interface to applications. Thus, it is transparent to the application whether the hands are controlled from a local device or via a VNC connection. Finally, enabling applications to link users to actions, authors extended the concept of hand morphs and allow for impersonation. This extensions to hand morphs manages required user information and provide an interface to applications. Application objects have access to the currently active hand morph and can ask this hand morph for credentials of the currently acting users. If the hand morph is not yet associated with an user, it opens a dialog asking the user to provide username and password. Based on that information, the hand morph is then associated with the corresponding user. Application support for multi-user multi-account interaction. Application platform, described earlier, enable applications to link users to actions. This in turn allows all users for acting on their own behalf. Now the question is how Project Talk makes use of this functionality. Explained as, the integration of SDG concepts further requires application developers to handle the upcoming additional issues regarding authorization. Additionally, content and functionality that is specific to certain users or roles must be offered in new ways, as the users interacting with the shared display may have different privileges. Both kinds of user-specific content and authorization have been addressed in the design of Project Talk. Project Talk realizes multi-user, multi-account single display interaction by accessing the information of the user that triggered the current event processing and links this user to HTTP actions. It consists of a client and server component that synchronize on shared data using the HTTP protocol. A user interface action that involves modification of data in the client results in one or more HTTP requests to the server. The application platform provides access to that particular handmorph object that represent the input, the channel of the user that initiated the current event processing. This handmorph object is also called ActiveHand.project. The ActiveHand is accessed by the client HTTP communication layer, retrieving the associated user and using corresponding credentials for the HTTP requests to the server. With that, Project Talk links HTTP request, which form the primary action of the client, to users, enabling them to perform all actions on their own behalf. Supporting this approach to multi-user, multi-account single display interaction, application developers have to consider additional authorization issues. A groupware that provides role-specific behavior is often designed in a way that users see only the functionality they have access to. In a project management software, only administrative users are able to create new projects. Users without these privileges cannot see this functionality. If multiple users interact with a single screen at the same time, the different users might have different privileges. It has to be respected that some amongst all co-present users sharing one display are not allowed to perform actions that are offered. This mismatch can be handled in 3 different ways. One way is displaying the collective set of functionality all users have access to. Unfortunately, users would be limited and could not use all features they are allowed to. Another approach is presenting every feature available to at least one user. As a result, users can activate actions they are not allowed to perform. Applications have to handle denied access explicitly and be able to recover from this error. The last possibility is to redesign the application so that, for instance, users are provided with menus specific to their privileges. The application design of Project Talk combines the second and the last option. For example, some users will not be allowed to modify user stories or move them between iterations. Still, all users have read access to these user interface components. Users unprivileged to perform a modification will experience a failure and receive a corresponding message. The menu for opening projects exemplifies the last option. For each user accessing the menu, it provides specific content, only projects the user is a member of. Code Talk. Conversations about code. Code Talk is author's approach to enable efficient informal communication about source code. Code Talk allows developers to mark and annotate single expressions, whole lines, or entire methods in the source code. It works similar to text processing applications and tools that are capable of adding comments to PDF files. The markup and annotations are shared along with the source code using regular source code management support. The need for communicating about code. Developers often talk about the source code of the system to be developed and extended. The source code itself is the most important artifact during the development process, in particular in agile development processes. Developers usually care much about it and prefer, for example, simple and elegant solutions over complex ones that are more difficult to understand and maintain. The system naturally evolves and is extended, so software developers spend much time reading code. However, parts of the system may be difficult to comprehend, raising the need to request support from the originators. An algorithm might be very complex, or the intended runtime behavior might be difficult to infer. Programs can also be written in different styles, making them more or less easy to understand. This leads to another kind of communication amongst developers, having the source code itself as the topic. During code reading, developers also often discover source code that needs to be revisited and improved. For example, variable or selector names can be too general and thus not very meaningful. Developers might further have ideas to simplify the system's design or even detect potential failures in algorithms. While these issues are often discovered during regular coding activities, developers may not have enough time or background knowledge to refactor the respective parts of the system or to validate their theory of a failure and fix it if necessary. Also, developers rather might to continue working on their primary task at hand. So, an efficient mechanism is needed to make the discovered issues explicit and share their insight with peers. Informal communication via markups. Current approaches to communicate about source code include source code comments and external communication tools and protocols such as email and instant messaging. However, both have limitations and do not provide adequate means to support informal spontaneous communication about source code. But this kind of communication is important. It helps to ensure a high code quality and helps developers to become better in their profession. This has been authors' motivation to design and develop a new approach to support this informal ad hoc communication. Developers might, for example, discover a message send calling an expensive operation. See the figure. Figure shows an example method in a typical code browser in Squeak. The statement selected in the figure enforces a full redraw of the entire scene graph, which can be a quite time-consuming operation. Developers might be skeptic about the necessity and mark the selected code as critical using a context menu or a keyboard shortcut. This will highlight the statement with a red background color. To additionally describe their opinion and thoughts, developers add then a note in the dialog that will be displayed next to the marked section, as shown in figure. This new annotation functionality code talk was integrated into the standard development environment, in particular into the tools for browsing and editing the code. So, developers can informally annotate a piece code whenever necessary during their regular code activities. The region of interest in the source code can directly be marked and annotated with an explanation. Annotations are an integral part of the source code, and as thus they are exchanged along with the source code itself. See the figure. Figure shows code talks markups that are shared through the SCM. When developers commit modifications applied to their working copy, they will also submit all annotations currently in the code base to the source code repository, as shown in figure. The critical question about the statement that forces a complete redraw is now part of the newly created source code revision. When team members update their working later, they will retrieve the newly added annotation along with source code modifications. They will notice the question regarding the redraw statement, and the authors of that code might either remember a reason for forcing the redraw or they might not. In the latter case, they might consider removing the statement, test the application to validate the assumption, and commit the modification. As the annotations are connected to the source code they reference, the annotations would be removed together with the referenced statement in the described scenario. If in the other case, enforcing the redraw is well-founded, developers can change the type of annotation from critical to normal and answer the previous question. Authors' extensions to the code browser enables developers to directly reply to questions or remarks in annotations so that a chat can evolve as shown in the figure. Talking about source code often involves other sources located outside the currently discussed context. Sometimes developers come across methods that seem to be very similar, but they do not have the time or knowledge to perform the necessary refactoring. CodeTalk allows developers to mark that issue and to reference the other method in their comment. For example, the chat in figure replaces the occurrence of string hash find tokens automatically with a hyperlink that browses to the method find token in the class string. The link below points to a method split that does not exist and is therefore drawn in red. The primary concept of CodeTalk is to separate the discussions about the source code from the source code itself, while keeping the connection to each other. This separation allows for individual support for the different concerns. Specially designed tools can ease the creation and exchange of annotations and can provide a better awareness of these issues. The direct connection between source code and annotations indicates that they belong together and thus encourages developers to keep both in sync. This may prevent the problem that occurs when the code gets updated with accidentally ignoring the corresponding comment. Case study. CodeTalk has been used by several development during a case studies that was carried with 80 students in author's software engineering lecture. Students formed 16 different teams, 5 each, were asked to develop applications in Squeak. The teams used an agile software development process such as extreme programming. The project's time frame was about 3 months. After the end of the projects, authors analyzed the source code of all revisions of all groups for markups. See the figure. Figure shows summary of markup usage from selected teams. As shown in figure, the analyzed projects are of similar size consisting of about 600 to 800 methods. While one team created 20 annotations, other teams created up to 100 annotations. See the figure. Figure shows absolute number of markups in the source code over whole project development time. At the end of the project's development, teams cleaned up all markups. Source was inspected by teachers at the end of the project. The average lifetime of annotations was 20 to 60 revisions, approximately a fifth of all revisions created during the project time. Developers started to use CodeTalk occasionally in the beginning of the projects and used it more often later on as shown in below figure. It seems that the need for conversations increases with the size of the code base. Authors further think that developers regard annotations as part of the source code and understand critical annotations as an indicator for insufficient code quality. All remaining annotations were addressed to the end of a project to make it ready for release. The example annotations listed above show that developers like to use a colloquial style for communicating about source code related issues. While there is no evidence whether the teams would have discussed a similar amount of issues without CodeTalk or not, authors think CodeTalk actually encourages this kind of conversations, which is important to bring all flaws to light. Conclusion. Authors developed a technological support for distributed development teams, the application Project Talk, and the development environment extension CodeTalk. Project Talk designed and developed for collaboratively managing user stories and planning activities. It particularly supports co-present team members by allowing them to act on their own behalf when simultaneously interacting with shared tools. CodeTalk realizes an informal yet efficient approach to communicate about source code collaboratively and over time. Design thinking and agile development seem to have much in common, also because both rely on skilled, motivated, and professional individuals and teams working creatively together. Thanks for watching. Comment for any suggestions. Like, share and subscribe for more videos.